Okay, this is the final example for section 3.4. So it's similar to the previous one. The first step would be to add this radical expression to the other side. You just want to get one of the radical expressions isolated. And I usually choose just to leave the one on the left. So that gives you this new expression. Now all you have to do is square both sides, and that's the easy part on the left. But the stuff on the right, generally I encourage people to write it out twice. And just proceed with the foiling procedure, or whatever you want to call it. But this times this is 4. This times this is 2. In front of that, this is the same thing. And those are actually like terms. And then the square root of x plus 3 times itself, or the square root of x minus 3 times itself, is just x minus 3. And then it's just like terms, we just have to put these like terms together. So subtract x, these go away. Subtract 4 and add 3. That gets all the integers to the left, gets all the x's to the left as well. So it looks like this is going to be a 4 on the left-hand side. And these are like terms. I know it's a little bit ugly, but they are like terms. 2 square root of x minus 3 plus 2 square root of x minus 3 is 4 square root of x minus 3. And then we're almost done. We just got to get rid of that radical. And so, this is your choice. You can divide by 4 now if you want. But let's say you forget to do that, like on one of your homework problems, that might not be exactly obvious. It's okay to square this expression. You just have to be really careful. When you square this expression, you get 16 here. When you square this, that goes away. So, in fact, you do end up having to reduce it anyway. So if you can reduce it earlier on, I wouldn't distribute there. I mean, you can if you want, but you could distribute the 16 is what I'm talking about. But you could just divide by it as well. So for this one, we're going to add the 3. And we only get one answer to check this time. All right? Which means most likely it works, but I'm still going to check it. You should check any solution that has a square root in it. Square root of x plus 5 minus the square root of x minus 3 equals 2 is what we're checking. So we're going to replace this x with, what was our answer, a 4? And so that's going to be the square root of 9. Well, that's 3. And that's going to be the square root of 1. Well, that's 1. 3 minus 1 does equal 2, so it does work. One solution, x equals 4.